let's talk a little bit more about our first presenter. I think he's around here somewhere because we're ready to kick this off, right? Mike, are you there? You there, Mike? Where you at, man?
Hello, hello. Can you hear
Hey,
me?
there he is. It looks like we're doing this again, huh?
Yeah, we are. I didn't know we were doing it from the barber shop. I would have been, I would have been joining you from the spa myself. But here we are, man.
Well, while you're doing that, I'm gonna start getting my hair cut. I'm gonna enjoy this very much. So
How
I'll let you take over,
how
Mike.
surprised would you be if my barber came in right now and we started? We did a dual
I
session.
should have told you. Yeah,
We should
you
have set
get
that
house
up.
calls made.
Okay, well, thanks, D. And yeah, I'm looking forward to see the snip. Hey, everybody, so welcome to Apply. So in case you don't know me, I'm Mike. I'm one of the co-founders of Tecton. I'm our CEO. And, today we got a lot of great content lined up. We're talking about recommenders today. Recommenders are super common. We've been doing a lot of work with recommenders, and we got content for basically all different stages of sophistication of recommender systems. So I'm just going to get my timer working so I know if I'm staying on time here. Lots to talk about. So today we're going to talk about, in this first session, we want to talk about the crawl, walk, and run stages for recommenders. So what are people doing at different levels of sophistication with recommenders? And after this, we have different talks of all different levels of sophistication and different, we've got a panel later. And then even at the end of the day, we have like a workshop where you can build some of this stuff on your own as well. So let's just dive into it. Recommenders, super common. I don't need to tell you about where all the different places we see recommendations. Recommend me a movie, recommend me a video, recommend me some music, a product, stuff like that. They're the most common problem in applied machine learning, I think. But I would also say that they're the most interesting problem. So why are they the most interesting problem? Besides being extremely common, they're just not a solved problem. There's not a perfect recommender, although we're going to hear from some people who have pretty close to perfect recommenders. Recommenders tend to be really high value also. So, it actually makes a very direct impact on your business. It tends to be, there's a lot of companies where the recommender is the main thing that makes the business work. So it's very important applied ML problem. And also for recommenders, they're the kind of ML problem where, putting a little bit more effort, putting a little bit more work into it from an ML team's perspective actually delivers really high ROI on those efforts. There's some ML problems where it's really hard to make impact. This is one where you can continually make impact on your machine learning, on the outcomes of your machine learning project. There's also a bunch of secrets in this world. There's a bunch of best practices that the best teams are doing, and they're trying to share these things. It's not a lot of like actually intentional secret keeping, but the point is there's a lot of like best practices that aren't really widely distributed or aren't really widely adopted. We're going to talk about some of that today, but there's still a lot to be done on kind of sharing this knowledge out there. And then particularly in recommenders as well, there's this interesting dependency between the algorithm and the architecture. So what does that mean? It means, if for me to try a new algorithm in recommenders, often it requires me to have a different data architecture or infrastructure and vice versa. So there's like this really interesting dependency between the theoretical side and the practical side. And in practice, these applied recommenders, there's a lot of applied practical considerations. How do we handle cold starts? How do we evaluate this thing? So there's a lot of questions that are not just the standard theoretical ML questions, but very applied questions. So we're going to talk about that today. In this talk, we're mainly going to talk about, hey, what are the different stages of sophistication? What's the crawl, walk, run phases of putting recommenders, building recommenders in your business, on your ML team? We're going to talk about this concept of unbundling the recommender. What are the kind of like core components that are behind the scenes here, and how can thinking about things from a component first perspective enable us to do more advanced things and get to that run stage? And then we're seeing feature platforms have a really growing role in recommenders. We're seeing teams adopt feature platforms more and more to implement a lot of this, and we'll kind of like touch on that along the way. So it's not really sequential stages. We're going to kind of touch on all of these along the way. So let's get started. Let's talk about let's talk about the crawl stage. So, very basic recommender, pre-computed recommendations. So this is creating recommendations offline and serving them to users online. So let's imagine I'm going to, I have to recommend some movies to someone who's going on my website. So I may pre-compute that list of all the recommendations for every single user, and then I want to serve it to them, load it up when they're loading the page. So, like, what does an architecture for this look like? Well, I have some raw data, and I'm regularly going to be featureizing this data. So I'm doing some process to compute features from this data. And then I have all of these features for every movie and for every user, let's say. And then I'm taking a model and making predictions on those features. And so this can be on a batch, on a scheduled process. This could be, every day, every night kind of thing, or once a week. And I'm generating a list of recommendations, say for every user. So for every user, I have this list of like 500 movies I want to recommend. And then those recommendations, say they live in my data warehouse, right? I need to make those available to an application, online. So I have some process to take those recommendations out of my warehouse and load them up into an online database. So I'm loading them up for online serving, and then my application, someone's loading the page, I'm pulling those recommendations and I'm serving to them. So yeah, there's a couple of stages here, but recommendation systems can be pretty complicated. And so this is a relatively simple version, pretty straightforward. There's some obvious pros here. It's simple operationally, but there's some like drawbacks of this. A big thing is that this is all offline, so it can't take into account any of our real-time signals, any context from the user right now. Like, is this user currently on mobile, or did they just look at this other video and I want to recommend them something related? And it can be kind of wasteful, like we're computing recommendations for every user, regardless of if they log in. We're doing a lot of compute ahead of time that may not ultimately be needed by anybody, right? The user may not be logging in tomorrow at all, so why would we compute all these recommendations for them? So that means it works only for a certain scale. So this is but the most basic thing. And in machine learning, we always talk about getting started simply, and this is a good step to get started with, right? It's really rough to kind of jump to much more complicated things out of the box. So we're seeing feature platforms kind of like, where does a feature platform fit when I'm building this kind of recommender? Helping with a couple of stages here. And this is kind of standard stuff, like, feature platforms helping us compute features on a schedule, managing this offline feature store, right? This catalog of all of our features. And then something that's a little bit kind of on the newer side, we're also seeing people kind of upload their recommendations or their predictions they make into the feature platform where this kind of online serving happens. So, people generate recommendations and upload into a feature platform. But overall, they're used for the general feature management and the serving of these predictions. Okay, so pretty straightforward. Now, so that was the crawl phase. Let's look at what a walking phase looks like. So walking phase is, where we're doing online ranking with real-time content features. Content features means features that are derived from, in the movie's case, like features about the movie or about the user kind of thing. So let's look at what such a system could be. So phase one, step one, we need to create a model. So we have our feature store, and this is online. So this is in production. In the feature store, you could, there's an offline component too. So we're pulling data from the feature store to generate a model, and we're deploying that model into a prediction service. And secondly, we're always computing new features, batch features, and loading them into the feature store. So now we can be confident that this feature store has the latest features about a user, about the content we're ranking, etc. So now, someone's loading the page, and the application needs to generate some recommendations. So it goes through a couple of phases. One, it needs to know, like, what are all the things I'm going to consider ranking or recommending. So it has to kind of generate a list of candidates. So it talks to some database or some service online, and it says, hey, give me a list of all of the candidates that I should consider ranking. So this is like a candidate generation step. And then we've got this list of all of these IDs for, say, all of the movie IDs. And now we need features for all of those all of those candidates. So it talks to the feature store and it says, hey, give me the feature vectors, the latest features for all of these movies. And the feature store can do, and the feature platform more broadly can do two things here. It's delivering the feature vectors, but also it can take into account some of the real-time context that the application is aware of to allow it to compute some features in real time. So there's some features that are pre-computed, like what is the genre of this movie, but then there's some things that can be computed in real time, like how similar is this movie to the movie you just watched 5 seconds ago, you just finished watching, kind of thing. And that requires some real-time context about this session. So the application gets back, say, batch, say, streaming features, and some real-time features for every movie, a pretty crisp feature vector. So now we have these feature vectors for everything we're considering ranking. And now we need to really score these and rank them. And so we pass all these feature vectors to a recommendation service. So this is the prediction and ranking service, and it scores. He uses these features to score and predict relevance or quality or whatever we're predicting for each of these candidates. And then we sort by those scores, and we choose the top 10 things, and we send that back to the application where it serves it back to the user. So this is kind of like the walk stage. Pretty complicated. I mean, there's like a lot of stages. It's not super complicated, but this is kind of this intermediate walk stage. There's a lot of pros, a lot of cons here. One advantage, this takes the user context into account. So we can do these real-time features, and a lot of use cases, there are a lot of places where you could use recommenders. The recommender would not even be valid if you can't use this real-time context. Like imagine anything with a query, like actual user input. You can't pre-compute that stuff. And it also kind of only does computation for users for whom they're actually logged in. So we're not generating a bunch of recommendations we don't need. So it can be a little bit more efficient. But there's a lot of operational overhead. Look, I got to maintain all these different services. I have a whole eng team run this stuff, and maybe different eng teams for different things. Someone's always on call for this. And it can be kind of expensive to run, just depending on data size. So if imagine I have 1 million movies, if this is not designed perfectly well, maybe I'm sending 1 million things back here, and then I'm generating 1 million predictions for every time someone's logging in. That can be expensive. There's ways around that, but that's just like the basic architecture can be, have some scale challenges. So this has a lot of advantages over the crawl stage that we just looked at. But for us to kind of get to the next stage of recommenders, we got to kind of take a step back and think about, like, what are some of the different components? What are some of the things that we're actually doing as part of a recommender system? And actually, before I get to that, let's just talk about like the feature platform. Where do they fit in? They simplify this quite a bit because they handle a lot of these more tricky data operations in the system. So they support generating this training data set. They are automatically computing features, say from streams and batches, and they do all of this. They handle all this real-time compute. So it just simplifies your architecture and makes it easier for you to build one of these online recommenders, because just more and more of this online of all this online infrastructure is handled by one system. So, but this is still pretty complicated. Let's kind of like break apart the recommender and talk about some of these different components. So what are these components? There's 5 components I want to talk about today. And, people might manage these taxonomies in different ways. The first component is the candidate generator. So this is about, what is it about? It's about just generating the list of entities that we want to be considering in our recommendations. So this could be, what's the list of all the movies? It could be something super simple, like just a basic query. Give me all of the items from the inventory. Very simple. It can also be more sophisticated. It can be something like, give me the list of the 1,000 users who have the most similar user history to me when I'm logging in, kind of thing. So there's a variety of levels of complexity you could have in this candidate generator, but its real responsibility is to create a list of things we're going to consider ranking. And in a lot of use cases, we actually may have multiple candidate generators and kind of take a union of everything, all of the candidates that they propose to be ranked, right? So, maybe you want your main candidate generator, but then you always want to make sure you're considering all of the on sale items. So you have another thing, just promote or propose all of the items that are currently on sale as well. Okay, so that's candidate generator. We get a list of candidates out. Second component here is a feature store. So the feature store takes in the list of candidates and potentially some real-time context for those candidates and generates a list of features, up-to-date features. It delivers a feature vector. So, what we're getting on the output of the feature store is this feature vector. It could be, 2 features. It could be 200 features for each item. And so the feature store handles generating the training data sets, so you can train a model, and storing all these values historically to make it really easy to generate these training data sets. It makes it easy to serve. It's responsible for serving these feature vectors in real time and at scale. And if you have a broader feature platform, it's computing all of these features on an ongoing basis, keeping everything fresh, and handling the real-time feature compute as well. So things that are important to consider here: speed, scale, making sure that the online data from the feature store is consistent with your offline data, and making sure you have a variety of feature types that you can support, because different ML models need a whole bunch of different feature types. And I'll just do a little plug, like this is the bread and butter of Tecton and Feast. So, it's something we may chat a little bit more about. But on the output here, you get a list of feature vectors. So we talked about generating candidates, getting features for each of those. And now we're going to do some filtering. So how do we reduce that candidate set based on some policies? So this is literally just like, I got some feature vectors coming in. I want a smaller set coming out. Why? To keep us either compliant or to keep us efficient. So and why would we want to reduce our candidate set? We don't want to recommend items that are out of stock, for example. We don't want to, so that's a simple example, but we can have more complicated examples. For example, we don't want to recommend a review if we determine that it is unhelpful, or if there's not safe for work content or something like that. So there's any number of policies. It depends on your business case, what's going on in your company, and how what kind of business logic they want the recommendations to have. But there's reasons why you would want to exclude things from being recommended, and that's what the filter stage is for. So then we have this filtered list of feature vectors. Now we got to do the scoring. So this is the ML part, right? We're using a machine learning model to generate some predictions. These predictions approximate things that we care about, right? So it could be we're approximating the relevance. We're trying to predict relevance. It could be we're trying to predict quality because we want to recommend the highest quality things. Sometimes, in a lot of recommenders, they use multiple scores, multiple different models to compute different things that they're trying to approximate. For example, if you're building an ad system and you're trying to recommend an ad, you might be estimating what's this ad's quality and this ad's relevance right now, and then maybe combine them at a later stage. So we get in a list of feature vectors, a list of predictions is coming out. And then the final stage is the ranker, just ranking all of this stuff. So we get all of those scores coming in. How do we turn them into a list of recommendations? So this can be something as simple as just taking this list of scores that's coming in and just doing a sort and taking the top 10 things and passing it back to the application. However, there's often kind of business logic that you want to involve in the ranker as well. Things like sometimes if you have those multiple scores, you want to combine them with different weights. So you may say, hey, I want to give 75% weight to relevance and 25% weight to quality. And then that's going to be my kind of like ultimate score that I'm sorting by. And there also may be other kinds of things you want to do in the ranker, like giving different boosts. So for example, if something's a preferred product or like on sale or promoted, maybe we want to just kind of like bump those things up a little bit. Or if it's something that, is a new item and we just don't have any data for it, maybe we want to like artificially bump it up so we can start collecting more data so we can generate better predictions, better recommendations for it in the future. So a lot of different things can happen in this ranker system. So we got these 5 different stages. I'm going to kind of click back. candidate generator, features, feature store, filter, scoring service, and ranker. Advanced teams use think about these things in these different components, and advanced recommenders are unbundled and use this component first approach. It unlocks a lot of really cool things you can do with in building your recommender system, and there's a lot of benefits. So it has a lot of like modularity, delivers isolation, classes between the different systems, and then allows for collaborative development. It makes it easier to experiment and iterate faster because different teams can own different components. It makes it easy to integrate with other different technologies. So I can kind of just like swap in a different candidate generator, swap in a different model scoring system, for example. And then I can mix and match these components to kind of build custom architectures that map well to my business. So I'm going to actually walk through an example of that. So that brings us to this run stage. Like how does components, this component-driven approach fit into a kind of more advanced online recommender? Well, let's take a look at that. So the first stage, my candidate generator, it's connected to some business data and it's generating a list of candidates. Going to the feature store. The feature store is connected to all of the other businesses data, and it's delivering a bunch of features for each candidate. And then my model is scoring all of those features. And then we're doing some filtering based on that. And then we're ranking things. And so, the filter and the scoring service, depending on your application, you can adjust the order of them. But then the application, it's talking to the system and it's saying, it's kicking off a process in the candidate generator. The ranker is returning all the details. It's returning the recommendations to the application. So you can see this is a lot more flexible of a system. And that's when we think about like the pros and cons of this system, that's a big part of it, is flexibility. That flexibility allows each of these different stages to scale independently to allow us to become the right level of efficient for the size of, for the scale of traffic and the size of data that these different components are dealing with. It also makes it easier for multiple teams to collaborate safely. Teams can operate independently and make changes to one system and not have to worry about kind of like some negative consequences on all of these other systems, especially because you have these systems built as different services, so there's not as much of like a monolithic coupling between them. That makes things that makes experimentation easier, and that also makes it possible to customize this architecture much more, and we'll look at that in a second. But just like the walk stage, this is even more operationally complex. Now I have different services that I'm running. Maybe I have different teams for each one of these services. This is pretty challenging. And, advanced ML teams, they have a lot of people working on this stuff and a lot of different teams that are owning each one of these different stages. And so let's look at like how the flexibility of this can be used to support a slightly even more advanced use case, a more customized architecture here. And so this is an example of that. So sometimes, we've got a lot of candidates that we want to score. Imagine I have, 1 million ads that I need to rank between. I need to sort between and recommend the perfect ad to my user, right? So I may actually, couple these things together and run 2 passes. So I'm saying, hey, give me, all 1 million ads, and then I have a lightweight pass, and then I have a heavyweight pass. So the lightweight pass is going to do a quick sort and give me or not a quick sort, but a lightweight ranking. And then I'm going to take the top 1%, for example, and do a heavier weight ranking. So what that looks like is, I have my 1 million ads, go to the feature store. I'm just going to get a couple of features, 2, 3 features, maybe 10, pass it through a lightweight model. Imagine this is something super lightweight, like a logistic regression model. And then I do some filtering and ranking. And so now I have, my 1 million ads has been sorted in a lightweight way. It's not perfect, but I'm going to take the top 1%, the top 10%, let's say, and I'm going to pass them through a much more computationally expensive ranking system now. This is one where I'm not going to put 2 or 3 features. Maybe I'm putting 200 or 300 features, or 2,000 or 3,000 features now for every one of those remaining 10,000 candidates kind of thing. So Now for 10,000 ads, I'm getting a lot of different features. So not at 1 million ads anymore. I'm just considering the top 10,000 ads, and I'm passing them through a model that is not a lightweight logistic regression. I'm passing them through a much more sophisticated deep learning model that is computationally a lot more expensive. But I'm okay using a more expensive model on this kind of like more limited set of candidates. And then I do filtering and ranking, and I'm passing that back to the application. So some of the more advanced, even like FANG recommenders, newsfeed kind of teams, big ad tech teams, they have multiple stages of this. This is just 2, but you can have 3 or 4, all kinds of things. But as you can see, this kind of like, this flexibility is helpful to help us build something really excellent here. It's something that maps to the business's need and meet our efficiency requirements and speed and stuff like that. But it adds a lot of overhead and it adds a lot of complexity. And teams at FANG companies that are working on this stuff, some of them literally have hundreds of people building this infrastructure. It's really hard to build and maintain this stuff. And for that reason, the right tooling is really critical here. You want to have tooling that allows you to spend as little time as possible on tooling, frankly, so you can spend your time working on the logic of your recommender system, making sure you have better recommendations, not worrying about the format of data that's coming out of one system and feeding into the other system and making sure they're compatible. So one thing that we're seeing lately is that we're seeing people begin to implement a lot of these stages in feature platforms, because there's a lot of similarity between a lot of these different stages. And so we're seeing kind of like feature platforms be used for a lot more of these stages and kind of grow to help out more and more with the broader scale online recommendation problem. So within a feature platform, you're able to define these a lot of these different stages in a single unified framework and have confidence that they're going to deploy as a coherent production application compatibly. So you're going to know that when you deploy this stuff, the candidate generator is going to fit into the feature store, and the filter is going to all work in a way that's plugged in well and deployed as a single application in with the ranker at the same way with the same DevOps flows and everything. So it's a way to have teams have more safety and more reliability in how they are deploying this stuff and maintaining the right speed of iteration while having while maintaining the flexibility that comes with this component-based approach. So when you use feature platforms, there's this, it enables this collaboration, right? It enables this kind of, it comes with this production grade reliability. You get to still have this like easy experimentation, so different people can still run different experiments and tweak the logic of different stages of your recommender. And with this fast iteration, it also comes with a really fast time to production, which is something that like feature platforms are excellent for from the beginning. And so in the Tecton world, we've been seeing this more and more, and we've been seeing people build more of their ML applications of their online recommenders in Tecton, and so we've been supporting more and more of these flows in Tecton. And so Tecton's growing to like a larger set of data flows in the ML application. So let's kind of just look at some examples here. Feature platforms handle, and this is kind of where we started, computing fresh batch features, stream features, computing real-time features, all of the feature management stuff you're used to, backfilling historical features, generating training data, serving features online. This is stuff that's kind of obvious and kind of bread and butter for feature platforms. Then logging these features so you can generate training data and do some debugging, tracking data quality, and drift monitoring is launching soon in Tecton. But then we began seeing people start implementing a lot of these other stages of online recommenders in Tecton, right? So people are uploading predictions into Tecton and serving those predictions through Tecton as well. People also started kind of implementing in our kind of online compute framework, they're implementing their filters and their rankers as well. And even doing some candidate generation and logging the candidate list. And so slowly it's kind of grown to be something that's become a really excellent framework for implementing these online recommenders. And so we're still early in a lot of these other stages, and there's a lot more we can do to make to become really excellent for these different stages. But it comes with this really nice advantage where you have everything work together compatibly, and in a way that allows you to not worry about the infrastructure. Rather than maintaining 5 different services in production, you just have this one framework, simple configuration to author this stuff and to deploy it all together. Supporting this online recommender use case is something that at Tecton we're doubling down on. So we are spending a lot of time over the next year providing first-class support for some of these non-feature store stages, right? Feature store, we're good, but like there's a lot more we can do in scoring, filtering, ranking, candidate generation. So if you're interested in that, get in touch with us, and I think you'll find we'd love to have some conversations with you. What's the advantage of this for an ML platform team? It allows you to run your online application, your online recommender, with a lot less infrastructure. Less infrastructure is needed. It means there's fewer people needed to run your ML application, your online recommender, less cost, less maintenance, and it comes with this kind of faster time to production, which is really nice. So this is kind of fresh, but this is a trend that we're really excited about. Okay, so what have we talked about today? We talked about the crawl, walk, and run stages for for recommender systems in production. We talked a little bit about like how do these systems unbundle, and what are the different components of online recommenders, and then the growing role of feature platforms along the way. We're seeing this trend of feature platforms beginning to take on more and more of the online recommendation algorithm or application. And that's just something that seems kind of natural, because as a unified online framework, it just makes it really easy to build some of these kind of more complex ML applications and manage them effectively. So actually, before I get to this, so we have, so that's it for this talk. A lot of other really interesting recommendation talks today. Different levels of sophistication. So stick around. There's stuff for beginners and stuff for really advanced folks. So we're going to talk about a lot of different things. There's always going to be something to learn for everybody. I just want to plug 2 more things. This is something that we've done pretty successfully in the past. A lot of times you kind of come and you see some of these talks, but then you're kind of like, hey, like, what does this mean for me? And I've found personally, even like building the ML platform at Uber, that I always got value out of meeting some of my peers, other people who are building ML platforms at a similar stage as me, so I could learn from them. So we've been putting together these kind of roundtable discussions really successfully, where this is what it basically means for you. You get to hop onto a Zoom call with 5, 6 other people who are roughly at the same level of sophistication, who are solving similar problems, and just talk about how you're approaching these problems. This could be about recommenders, could be about ML platforms more generally. This is pretty interesting. I've hosted a couple of these. I've found it really useful. So I really encourage you to sign up for that. We're organizing a bunch of them after this conference. And it's just also a great way to do some networking. Secondly, if you have some questions about like Tecton or Feast, or just ML platform strategy generally, and you want to talk to us at Tecton and Feast, we are doing kind of one-on-one advising sessions. So you can just sign up and have a meeting with myself or an expert from Tecton and Feast. So the link to sign up for that is in the chat. But also, if you're like watching this on video later, scan this QR code, and that's the sign up link. Okay, thank you very much. Hopefully this is really useful for you, and there's some really interesting talks right after this, so stay tuned.
Amazing. That was awesome, Mike. You got a minute for a few questions?
I got a minute, yeah.
All right, so we got time for one question, and I want to just address something that I saw in the chat that was a big question, and I will answer this question. Your question will come up in just a sec, Mike, but people were asking about the difference between Tecton and Feast, and at the end of today's event, the last slot is going to be a workshop with Tecton and Feast and using them to build recommender systems. So you'll get to see all the differences there. the question for you that I thought was awesome, Mike, is where does a vector database come into play? Can a feature store replace that?
Great. So vector databases are a new technology. They can help with various stages here. So often they can be. If you saw, I had a slide that was saying, "Hey, the candidate generator." You can have more advanced candidate generation than just like give me a list of all of the items. You can have a. It's kind of funny watching you get your haircut. You can have generation that is like give me the most relevant users, the most similar users to me. And so vector databases are really good for doing this kind of like finding me a lot of similar items to this particular item. um, that doesn't mean that they necessarily implement all of the logic of like a broader recommender. And so as we talked about, like in practice, recommenders tend to have a lot of different places where you want to inject business logic for different reasons, do some filtering, implement a policy, do a more advanced type of scoring, and or experimentation on a different stage. So I think of like vector databases really useful for that, like generating that initial list of things that we would want to consider ranking, and then the recommender application doing the proper like let me sort all these things in the right way to generate those final recommendations.
Awesome, dude. Thank you for that. And thanks for this chat. Every time that we
I can't wait to see what it's going to look like at the end.
I just love it because I literally try to just get you and make you, like on Saturday Night Live when they make people break. That's basically what I try and do with you every time that we do this.
And live from New York.
Most outrageous shit. So right on, man. Well, thank you. And you'll be back to moderate the panel that's coming up. So
I'll be back. Yeah. We got a really cool panel in a little bit. So stay tuned for that.